So a little while ago I spotted this thing on eBay. Couldn't really tell that much about it from the pictures. I sort of figured there's probably at least a helium neon laser and an argon laser in there, which of itself was not that interesting. So I couldn't really see that much detail. The price was a little bit higher than my sort of buy something for the hell of it threshold, although it was fairly local. So I sort of let it run and no one bid on it. So I just sort of said, well, what the hell, I just emailed the seller with an offer quite a lot lower than their opening price, and they accepted. So I just trundled down the road to pick this up, and this actually has got so much stuff in it that it's going to warrant probably 2 or 3 videos. So I just wanted to do a very quick overview just to give you a taster, and also to see if anyone's sort of got any information or anything that might be useful when I start digging into this. I have tried firing it up, but all I can get is some fans going. I think it needs quite a lot of interaction from the control PC. Now, basically what this is part of what's called a confocal microscopy system. And I've only really skimmed through sort of the info I could immediately find online, and basically the idea is that it can produce laser light that's used to excite fluorescent dyes in biological samples, and this is then scanned over a sample with very precise focusing, so you can actually extract high resolution and even 3-dimensional information by controlling how the laser is focused within the sample. Now, so this is only sort of part of the system. This big box here is basically the light source. This has got all the lasers, which I'll have a close look at it in a minute, and then there's this sort of captive umbilical cable to this head unit, and I think this is what does a lot of the scanning and a lot of the other laser, the other sort of microscope stuff. And there's a lot. I mean, just this head unit alone is probably going to be at least 2 videos, if not more. There's just a ton of stuff on that from what I can see on the surface. Loads and loads and loads of optical and electro-optical pornography going on inside that, so I think that's going to be a really interesting teardown. So quickly go back to here. So the one thing I thought almost certainly was in here was an argon laser, which is true. So this is the argon laser here, the main sort of body, sort of big rectangular casing. Argon lasers are getting pretty obsolete now because most of them have been replaced by solid state, but typically they're quite appealing because they take ridiculous amounts of power, typically about 1 kilowatt or so, to put out maybe sort of 10 to maybe a couple of 100 milliwatts of laser output. Now, looking at this, some of the clues, about the only clue that I did get was the control panel. I've torn out some of these key switches, but basically this whole unit basically forms a table. I had to take the legs off to get it into the car, but this acts as a table to put a couple of PCs on, and there's this sort of control panel that sits above the table. I've found a photo somewhere of the system that I'll include here, but you've sort of basically got some various on-off controls, and there was a bit of a clue, like for example here it says sort of laser, argon stroke, argon krypton, scanner laser, and here are helium neon 633, helium neon 543, 594, so we've got some different wavelengths going on here, and then level, so this will be the power level for the argon krypton laser. And I think this system comes in a whole load of different configurations. When you order it, you tell it, which permutations of lasers you want in there, because obviously depending on the sort of work you do, you're going to want different wavelengths. I think this is one of these sort of things where there's a whole shopping list of different options they then build to order depending on what you want. So if we look down at the rating plate on the argon laser, now it says 500 milliwatts maximum output. Now that's going to be way more than it actually puts out. That's purely a safety rating. But it also says wavelength 450 to 530 nanometers. Now argon has, from memory, I think either 7 or 8 lasing lines, and argon lasers typically come either as a single line, most commonly 488, or multi-line. Now the nice thing about the multi-line ones is if you sort of stick them through a prism, you get this really beautiful array of all the different colours from sort of blue up to green coming out of it. So that looks like it's probably a multi-line argon laser. We've got a big air duct here, so these things typically, I haven't got as deep as the rating plate on this, but the power consumption of these is of the order of 1 kilowatt or so. So there's a massive weight fan in there. There's also an airflow sensor on here which doesn't appear to be connected. I don't know if that's a piece missing or they can never bother connecting that, which tells you, that you've got airflow, because these things, if you don't have it, if your airflow gets blocked, you really want to switch it off, because otherwise it's going to destroy itself fairly rapidly with a sort of kilowatt of power going through the tube. So this argon laser sort of comes out through here. Most of the lasers seem to have this. I'm guessing this is probably just an on-off shutter or possibly a beam intensity control Can't quite see what's written on that that label there, but say all the lasers seem to have these units on them. And then this goes through to this block. Now, one thing I did find when I was hunting around for info, and also it's mentioned here, is this AOBS. Now that stands for Acousto-Optic Beam Splitter. This is a very clever electro-optical device that basically appears to select a wavelength based on an electrical signal. So it's like an electrically tunable prism, which is rather an interesting piece of tech. Also here, for example, here it says sort of a caution, AOBS must be connected before turning on. Now these things, like a lot of electro-optical devices, use RF excitation, so you can see on these boxes here it says RF out. And one of these boxes, say two of these, the RF seems to go out to the head unit. This one actually connects down to here. So what I think this is probably a wavelength selector that can select one of the however many argon laser lines to then output to feed into this. So this goes into here. This is an armoured fibre optic cable, and this actually sort of spins round and round in circles, but actually goes into this block here. So I think this is where all the lasers are combined. So on the top here we've got this is a helium neon laser, and unusually this is 594 nanometers, which is yellow, which is fairly unusual. You can actually get helium neons in red, yellow and green. The yellow and green ones aren't particularly common. And at the bottom here, you can just about see it, there's another helium neon, so I'm sure this is going to be the red helium neon at the bottom. And in the middle here we've got a solid state laser. This is 564 nanometers yellow by Melez Griot, with a nice sort of expensive LEMO connector going into it. Now that goes out here, but unfortunately I haven't got the controller for this. I have emailed the place I got this from just in case they've got it sitting around somewhere, but it may be possible to actually get that running to some extent just by firing up the laser diode, but that's going to have things like thermoelectric coolers and temperature stabilisation for all the optical parts, so whether or not we can actually get any light out of that, I'm not sure. But sort of a yellow solid state laser, I think it's 34 milliwatts at 564 nanometers, so that will be a really fun thing to get working if I can. So I say this, I imagine what's in here are probably things like wavelength specific beam splitters, or possibly some motorised mirrors to flip whichever wavelength you want into the actual beam path. There's a huge great big block here, I've no idea what that is, but that appears, as far as I can see, to be connected to this block here, which says, so these boxes, there's three of these which are all the same, which say MOT.NC, which are RF generators for acoustic purposes, but this one's different. This one's got a USB input and it says MDS multi-digital synthesizer, so maybe that's something it produces different frequencies or something for a different type of acousto-optical device. There's probably something different going on in inside this box here, so that's going to be quite interesting. Over here we've got a 24 volt power supply that was sort of rattling around a little bit, just jumped off its DIN rail. And underneath these two boxes, this is the power supply for the Argon laser. Argon lasers, their running power is typically the order of 1 to 200 volts at somewhere around the 5 to 10 amp DC range. And there's also a fairly high current filament and a high voltage igniter. The igniter will be inside the Argon laser thing, so they need a high voltage to strike. But once they've struck, the running voltage is of the order of sort of 100 to 200 volts. And you adjust the output power by adjusting the beam current. And there'll probably be some optical feedback in here, because generally what they do is you can normally set them up so to give a constant output, and it'll actually adjust the beam current, because as the tube ages the current goes up to get a constant output. Mains input over here, we've got two 16 amp AC connectors. There's another connector here, it says fan supply output for that, so that's maybe for some cooling fans for another part of the system. These go into just multi-pole circuit breaker here. And it says the current draw on here, it's on the two inputs, 12 amps and 12 amps. That's so you can just run it off two separate main sockets, so you don't need any special wiring. So maybe it's the lasers and everything else. I haven't really looked at where all these go to, all the cabling's in sort of nice neat trunking. As I said, I couldn't get it to do anything from just powering up, so I think I'm just going to have to basically take all this lot apart and try and get all the optical parts running separately. Quite a few of the parts have got this Lazos name, which is not a name I've heard before. I don't know whether that's a name, because I know quite a lot of companies in the laser game have been taken over time, so I don't know if that's a takeover thing or whether this is maybe an integration company that takes all these components and puts them all into one box to provide this, because it wouldn't surprise me if something like this might not be made. Incidentally, this is made by Leica, this system, so I don't know whether Leica actually manufacture all this or whether they sub out all these optical assemblies to like laser experts to produce the sub-assemblies. Might find a bit more information as we start digging. Down here there's just a big power supply, so this is just going to be running all the various systems. There's a big mains filter down there, and there's also a blower here, and this just goes straight out into a tube here which goes up to the head. That's probably because obviously this is sort of microscopy. What you don't really want is a big noisy vibrating fan messing up your optics. So I think the idea is that's just to provide a bit of air cooling without the vibration of a fan. If you look at the picture of the setup, this big table has got all the PC sat on it, and there's another table with a microscope set on it, and it wouldn't surprise me if that other table is maybe filled with like sand or concrete or something to provide a nice heavy sort of stable stand, but it's clearly mechanically separate from the this part. Right, this is the head unit. Unfortunately it doesn't unplug. There's just sort of this really cumbersome cable assembly with sort of all the electrical cables, the fibre optic cable for the laser output, and this air cooling hose. So it's about 2 meters long, and it makes the whole thing a bit cumbersome to handle and fragile. And this thing has been bashed about a bit. There's a few bits sort of that have fallen off and dented, so this hasn't been treated with the respect it deserves for what time. I'll be highly surprised if this had an original price tag below 6 figures. If anyone knows anything about it, I'll be interested to know. I'm sure even just the optical microscope bits must have been very expensive, but this whole thing is clearly a very expensive piece of kit. Incidentally, that this is the power block here. This is where you plug all your PC stuff into, and there's this cable here, which I'd imagine goes into either SCSI or a custom I/O board into the PC. There's also a ton of connectors on here. We've got shutter, UV, krypton IR, helium cadmium, so there's obviously all sorts of different options on this for different types of lasers. So, and it could well be that some of these are for completely external lasers that have their own feed into the system in some configurations. Stepper, IR, UV, helium cadmium again, probably some sort of mechanical stuff. There's an interlock connector, some COM ports, panel box, presumably some sort of control panel or something, trigger out, AOTF, I'm assuming that's acousto-optical something or other, something filter perhaps, UV, EOM, which would be electro-optical modulator, IR on this box. And this side of the head, we've got all the various cables coming in. There's quite a lot in here. There's some boards on the top here with actually unplug. Yeah, this says Microware, who I believe make operating systems. It's got a Motorola chip on there, and LSI. This FPGA 1, FPGA 2 version numbers. I can't immediately see any FPGAs, but that label may apply to this whole board assembly, so there might be some FPGAs buried under here somewhere. There's actually, well, in fact I've just noticed there's actually a back plane down here and just a ton of other boards down here as well, so this is going to be a long job, this one. And about the only thing you can see, there's a couple of stepper motors here, and this one, you can actually see if I rotate this, it's rotating some sort of assembly here. It's got a flat flex connector on it, so maybe that's perhaps something like a polarization rotator or just some sort of mechanical thing doing something with the optics. So there's this other stepper motor here, and we've got the air is sort of coming through this ducting here and going into here. I think this, yeah, I think this entire thing is one big like machined optical block. Let's see where, yeah, and this is machined out a fairly major chunk of aluminium, I think. And we've got this separate sort of grey piece here, Again, fairly solid chunk. Looks like we've got some mechanical rails here, so that's maybe where this mounts into the whole system, and there's some sort of optical connector there, whether that's the output or whether that's the inputs from other lasers, I don't know. There's something going on here. It looks like there's maybe some sort of spindle, perhaps there's a chopper or something. I just noticed one thing I sort of found sort of locking around loose was this piece, and it wasn't really obvious where this came from. I just noticed this does actually match up here, so I think that actually came off of here, and that's got another fibre optic coupling on it, so that's, again, whether that's from another laser or something, I don't know. There's some labelling on here which is a BP 500 to 550, 560, 607 to 683, so that's going to be some sort of beam splitter or wavelength, filter or something, because there's quite a few. There's sort of an opening there, one there, another one on this side, and another one there. So again, whether that's the output or some inputs from another laser or something, I don't know. But that clearly was originally screwed into there, but that's come off at some point. Actually, I can just see a bit of flex cable on there, so there's probably another rotating assembly in there, but I can't actually get at the motor. So let's take a look at the other side of this head unit. Right, so on this side there's a few more connectors here. XY stage, obviously that's for some sort of motorised stage on the microscope. Again, Z stage, similar sort of thing. Trigger. Transmitted reflected. Now I'm guessing that may be some light for the actual light sensor, so that's we've got some controls or some inputs from maybe photomultipliers or image sensors or something. So, and we've got probably two optical paths for transmitted and reflected light. I just noticed there's I'm assuming that's interlock now. I wonder if that might be the reason I couldn't get anything to turn on. I might see if I can, assuming it's the same connector as this interlock connector here, see if I can actually put a plug in that and see if I can, because it may well be that there's a plug from the microscope body that goes on here, so that when you detach the two, that comes off so you don't get lasers sort of flying out of the open aperture. So it may be the case that that's just an additional interlock that's connected into the microscope to avoid any lasers leaking out. Here's the part number sticker, December 2004 manufacturing date, although I noticed a date of 2010 on the Argon Laser, so maybe that's been replaced at some point. Again, there's 2004 down here on this bottom bit. Now there's this sort of bit that's sticking out here, and that just says sort of stepper 1, stepper 2, and from what I can see inside, it's a bit hard to see, but it looks like there's just a multi-pin connector, so I wonder if that's maybe just some stepper motor drivers that have been pushed out here just for heat dissipation, because obviously this thing is going to be quite sensitive to vibration, so you don't want to have fan cooling, so that's probably why they've just sort of taken this thing and stuck it out on the side, just to get some heat transfer without having to have a fan in there. Right, we can see a few more things. This is the other side of that rotating assembly, so we can see a flat flex cable on there. Quite a few. There's a little bit on the end here. There's some sort of device down here. I don't know if that's a sensor or something. Oh, it says position depth, so yeah, that'll be some sort of maybe position sensor. There's another piece that comes up here with what looks like a little mirror on the side, and some sort of aperture there. Looks like there's sort of a hole there, but there's no obvious way. I don't think this rotates, so again, that's probably an option. Yeah, no, I think that's fairly fixed. This is the armoured fibre coming in with a laser light, so the laser comes in here. Then looks like there's a mirror, then that disappears into this central block, which seems to be a separate part to the main unit. So that's saying AOBS, that's maybe the acousto-optical beam splitter. And in fact here we've got labels on these cables saying AOBS Crystal 2 and Crystal 1. Yeah, they both seem to disappear into this section down here. I think that it says polarization filter wheel, so that's fairly self-explanatory. There's something going on here. I don't know if that's just an adjustment or something. We've got the other side of this big, this big grey thing. Some sort of mounting slide here, but this seems to be fairly sort of completely enclosed. So there's probably something interesting going on in there. Little ribbon cable going into it, and you can just see the other side of that back plane. So there's quite a lot of electronics, quite a lot of boards in here. So we're going to have to There's actually another backboard. I think that's maybe the board that all the rear connectors are mounted on. But this thing is very, very densely packed. There's a lot in here. And there's also a GSI Mnemonic, which I think is a Galvo scanner, which could be quite interesting. G325D, I found that quite a lot in the context of like show laser scanners and so on, so that could be quite a fun little gadget to play with. Yeah, so there's this, where it comes in, there's a little board on here, so I'm guessing that's maybe a sensor, optical sensor. And actually I can just about see down there in this bottom section there's some feed-through caps. Obviously if this thing's RF driven, this is going to be a sort of a nice RF sealed thing. See some feed-through capacitors going into that section there. But that's about all we can see. So there's a little bit on here, some sort of motor or actuator there. Maybe I think that might be some sort of exit, but and in fact also there's some blanking panels here, so it may well be that again these are for options for different versions, but yeah, I think this is going to take quite a while and quite a few videos to get through thoroughly. So if anyone knows anything about this system in particular, I'd love to know how much it cost. Anyone knows anything about these beam splitters? I haven't yet done much searching online to see if I can find any data on this stuff. I found the manufacturer of these. I couldn't immediately see any data, but I'll see if I can find out anything, and any of the usable optical parts I'll try and hopefully not destroy too badly and stick them on eBay as and when I'm finished with this thing. So I'm sure there'll be some people that might want to play with some of this stuff. Might be a little while before I get through all of this, but I thought I'd put a little taster up because it's probably one of the most interesting bits of kit, particularly as I didn't really know what it was until I actually got it home and started looking at it.